Hello students, so in this lecture also we'll proceed with the 8086 microprocessor instruction set. So the next group is miscellaneous data transfer group. So in this group, so the first instruction that we're going to deal is XCHG. So what is the function of XCHG instruction? This instruction, it exchanges the content between the source and destination. The format for writing this instruction is this XCHD destination source. So what it does, it exchanges the content between the destination and source. I'll give you an example. So one more thing that I want to tell you here is both the destination and source cannot be memory locations at the same time. If one of the destination is memory location mentioned in the instruction, then the source has to be registered, or it cannot be memory location. Then the source and destination both must be words or bytes. So the exchange should be between when we are exchanging, when we are using this instruction and when we are using destination and source. So both the destination and source either should be word or byte at the same time. It cannot be like one destination is byte and the word and the source is word. So the content exchange should take place between two registers, or between between the destination and source, and the exchange should be either word or byte. Means both the destination and source should carry word or byte at the same time. We cannot use segment registers for this type of instructions. The example is XCHG let's take this example, XCHG BX What it will do, since BX is also carrying a word, CX is also carrying a word, and I have told you that both the source and destination should carry word at the same time or byte at the same time. So since here both the source and destination are carrying the word, so word exchange will take place between BX and CX register. Similarly, the next example is XCHG 5000H, AX. So 5000H is the offset of the operand, and here since AX is AX is the accumulator of 16 bits and it is containing the word, so word exchange will take place. And how the exchange will take place, the offset that is mentioned in the instruction, the content of this memory location will get exchanged with the accumulator low, and the next offset or the next memory location, the content of the next memory location will get exchanged with accumulator high. So in this way, accumulator's content will come into the memory location, and memory location's content will get into the accumulator. The next instruction of this group is LAHF instruction. This instruction, it copies the content from the lower byte of the flag register and it stores it into the higher byte of the accumulator. SAHF instruction is just the opposite of LAHF instruction. What it does is stores the content from the higher byte of the accumulator. It stores the content from the higher byte of the accumulator and stores it into the lower byte of the flag register. The next instruction is XL80. This instruction, it replaces a byte in the lower byte of the accumulator register with a byte from the lookup table. So how we get to know which byte from the lookup table? So the starting address of the lookup table will be given by the BX register, and the offset, or you can say, and the actual address from where the byte is going, from where the microprocessor is going to take the byte and store it into the lower byte of the accumulator, that address will be obtained by adding the starting address of the lookup table with the AL register. So then we will get the actual address of the content, and that operand will get stored in the accumulator, lower byte of the accumulator. Next instruction is IN instruction. It copies a byte or word from the input port mentioned in the instruction and it stores it into the accumulator. If a byte is being copied from the input port, then it will get stored in the accumulator, in the lower byte of the accumulator or whatever is mentioned here. And if a word is going to get copied, then it will get stored in the 16-bit accumulator AX. We know that the 8086 microprocessor is having a 16-bit accumulator, and it can also be used as 8-bit accumulator like accumulator low and accumulator high. Then next instruction is out instruction. It copies a byte or word from the accumulator and it copies it into the specified output port mentioned in the instruction. Either a byte can be transferred or a word can be transferred depending upon which what is written here, whether it is accumulator low or AX or accumulator high, whatever is written here, according to that a byte or word will get transferred from accumulator and it will get stored in the mentioned output port. Now coming to the next group of instructions, arithmetic and logic group of instructions, and here we are going to study about the different arithmetic operations. So till now we have studied about all the data transfer group instructions where flags affected were none, because there was no arithmetic or logical operations taking place in the instructions we have studied till now. Now since we are going to start the arithmetic and logic instructions, so the flags will get affected, and I'll tell you which flags will get affected. We know that 8086 microprocessor is having all total of 9 flags. So among that 6 flags will get affected as per the arithmetic and logical operations, and the remaining 3 flags, that is trap flag, direction flag and interrupt flag, they have different roles, so they won't get affected through this arithmetic or logical operations. So starting with the first arithmetic operation, addition operation, the instructions that are used under this addition operation in the 8086 microprocessor are ADD, ADC and INC. ADD instruction, what it does, it adds the content of the source and the destination and it stores the result in the destination. So source and destination can be anything. It can be memory location, it can be register, and one more thing, source and destination cannot be memory locations at the same time. Moreover, the source and destination both must be either word at the same time or byte at the same time. Now the next instruction is ADC, that is add with carry. What it does, it adds the content of the source with the content of the destination, and the content of carry flag also gets added and the result gets stored in the destination. So here also for ADD and ADC, I have told you that source may be, it can be immediate number, it can be registered or memory location. Destination can be registered or memory location, but both source and destination cannot be memory locations at the same time. Flags affected, all the 6 flags will get affected. Next instruction is INC instruction. What it does, it whatever register is mentioned here, it adds 1 to the content of that register mentioned in the instruction, or the destination, whatever destination is mentioned here, it adds 1 to that content, means it increments the content of that register. So flags affected, auxiliary flag, overflow flag, parity flag, sign flag and zero flag will get affected. Carry flag is not affected, because if the content of 8-bit register, suppose suppose like I am using this instruction INCAL, and if the content of AL is FF, that is the highest 8-bit number is present in the AL, and if I am using the increment instruction, then what will happen, after INC instruction, content of register will be 0 without affecting the carry flag. So it will go in circle. If it is the highest content, after incrementing it will become 0 0. So the carry flag doesn't get affected in increment instruction, as just like as we have studied in the 8085 microprocessor also. Now the next arithmetic operation that we're going to deal under this group is subtraction operation, and under this the instructions that we're going to use are SUB, SBB, DEC and NEG. So what does the SUB instruction does? It subtracts the content of source from the content of destination, and the result gets stored in the destination. Similarly, SBB with borrow, what it does, it subtracts the content of source from the content of source and the content of carry flag from the content of destination, and the result gets stored in the destination. Again, for SUB and SBB instruction, both the source and destination can be source can be immediate number, source can be register, or source can be a memory location. Destination can be register or memory location, and source and destination cannot be memory location at the same time. So and one more thing, source and destination should be either word at the same time or byte at the same time, and flags affected, all the 6 flags will get affected. Next instruction under subtraction operation is DEC, that is decrement destination. What it does, whatever the register is mentioned here, it subtracts 1 from the content of that register, means it is decrementing the value of the content of this register. So destination may be stored, the destination may be registered or memory location. Flags affected, all flags will get affected except that trap, directional or interrupt, that is not going to get affected through this arithmetic operation. And one more flag will not get affected through this decrement operation is the carry flag. So if the content, how the carry flag is not getting affected, let me give you an example. So if the instruction is DECAL, and if the content of AL is 00H, means the lowest 8-bit number, and if this instruction is getting performed, then what will happen, due to decrementing of instruction, AL content will get FFH, means it will work in cycle without affecting the carry flag. Similarly for 16-bit instruction, 16-bit operand also. Now the next instruction under the subtraction operation is NEG instruction. What it does, it replaces the number in destination with the 2's complement of that number. So the destination can be a register or memory location. Flags affected, again auxiliary carry flag, sign flag, parity flag, overflow flag, and zero flag. So all the 6 flags will get affected. So let me take an example. Suppose an EGAL is the instruction and the content of AL is 35H, and if you write 35H in binary, you will get this 35H. So after execution of this instruction, what will happen, 2's complement, if you find the 2's complement, how to find the 2's complement, you all might know that if the 35H is 0011 and 0101. So for this instruction, what will happen, 2's complement of this operand will happen. So for 2's complement, first you need to perform 1's complement. So for 1's complement, all the zeros will get converted to 1 and 1 will get converted to 0. And then for 2's complement, we need to add 1 to the 1's complement and we'll get 1 1 0 1, and this will be 0 0 1 1. So here I've written also. So this is equal to CB. So CB will get stored in the AL. So what does this instruction do? Whatever destination is mentioned along with the instruction, the content of that destination, 2's complement will occur to the content of the destination and will get stored in the destination only. So I'm ending this lecture here. We'll continue with the 8086 microprocessor instruction set in the next lecture also, and we'll start the multiplication operation. Instructions for multiplication operation. Thank you.